Alright everyone, welcome to the video on chapter 4.2. This video will be a little quicker than the last one because there's a lot less content to take in here, but there's a lot more skills you're going to have to practice outside of class. So let me go ahead and get started on this. The first one here is the idea of demography. Demography is just the study of human populations. We look at the birth rate, the death rate, how humans move around. That's immigration, emigration, two terms from the last chapter section. And that's really all it is. It's just the study of how humans' populations work. So, this is the chart I showed you guys in class. This shows you the human population growth for the last 2 million years. So, basically, if you look at this is over here in billions, this is over here in time. About 2 million years ago, we barely had a few million people on Earth tops. Not very much. Population was low. I would think it would be lower than this. I think this graph does not do a very good job showing it. I know around 2 million years ago, the population on Earth was pretty low. If you look here, not much changed for a pretty long time. Plowing and irrigation, these are two farming techniques, as you can see, started right here, and that increased the population for quite a while until the Industrial Revolution occurred, in which you begin to see exponential growth taking off, where today we have around 7 billion people on Earth, so we'd be somewhere around here, right here. Now, the interesting part about this graph is just showing you how human population had a carrying capacity that was pretty low for quite a long time. But with the advent of different technologies like the Industrial Revolution, plowing and irrigation, you begin to see increases in population over time until we get to the modern era when you see a huge skyrocket in populations. Now, a lot of people have asked questions about why this population increase happened, and a lot of people attribute it to two things. The first one is industrial farming. That's when we began to farm on industrial scales, and we were able to take advantage of fertilizers and chemicals to help increase how fast food would grow. It was a pretty big leap forward for humanity on that. The second one, which was pointed out in class, in every single class, which was very impressive, guys, is that it was modern medicine techniques. You no longer had to worry about children passing away due to diseases. What used to be the big control for the human population was disease and starvation. I think I told you guys in class that it was very common to have around 10 children back in the day and only have about 7 of them survive. Only have 3 of them survive, 10 of them would die. And that's huge. That's ridiculous. 70% of your children would die. However, modern medicine has totally changed that. Now, all of a sudden, rather than having so many children die, almost all of them are living. It's a major change, and it's causing human population growth to skyrocket because we're no longer having the limiting factors of disease and famine controlling us the way we used to. Now, one question I asked you guys in class, and something to consider, I don't have an answer to it. It's something you guys will have to find out in your generation is, what's our current carrying capacity? As you know, in both models, both the exponential and the logistic, it'll keep going up. How high can we go? I've heard numbers as 10 billion, I've heard 20 billion. Nobody really knows how high we can get, what our carrying capacity is right now with modern technology. And it's a good question. It's a very interesting one, and I'm hoping we're coming up to a good answer here soon before we go past our carrying capacity, because what I talked about beforehand, when a species goes beyond their carrying capacity, that usually causes death. So, the first idea this chapter talks about, this is the idea of demographic transition. Now, beforehand I told you populations used to have high birth rates, so lots of babies, and they used to have high death rates. 7 out of 10 of those babies would die. Now, the demographic transition is going from that type of situation, we have high birth and high death, to the opposite, which is low birth and low death. This is usually considered very good because it means that limiting factors like food, education, things like that aren't going to be hurting us as more because we have a lower birth rate. Fewer babies are being put into the world. These countries usually have very low population growth rates. You wouldn't look for something below a population growth rate of 1. There is a second way to check as well, and I'm going to go over that here in a minute. Countries that are not in demographic transition rates usually have high birth rate and death rates, or they have high birth rates and low death rates. A good example of that would be Afghanistan. Afghanistan has a population growth rate of 4.22, which is very high compared to most of the rest of the world. And that's because they've benefited both from modern medicine, so the babies aren't dying anymore, but they haven't gotten to that point where they begin to have the low birth rates too. So women are still having 10 children, but they're not having 7 of them die. They're having 10 children, and all of them survive. That's causing some economic issues for them, and it's also bringing them to their carrying capacity faster. Here's a chart of population growth rates from a couple of countries around the world. I'll give a couple of quick things so you guys can see how to determine if it's in transition or not. Afghanistan is 4.77. They are definitely not in transition. They have a very high birth rate and a very low death rate, so they are not in transition. Their growth rate's far too high. It needs to be below 1. Brazil is at 1.06. They're scary close. I wouldn't give you a question this close on a quiz because it's one of those areas that's debatable. You could argue it both ways. I would say they are moving towards transition and they're almost there. Bulgaria is the opposite. They are at negative 0.89. That's a country over here, if I'm not mistaken. And he goes, these guys would be in transition, but they're also losing population. It would be interesting to see why this is happening, because I have no idea. Germany is definitely in transition. If you look at that number, they're at 0. So essentially, they're not growing at all. They're staying neutral. Honduras is not in transition. Not in transition for India. Indonesia is not in transition. Kenya is not in transition. Niger is not in transition. Nigeria is definitely not in transition. United States is just passing transition. We're still growing. I would sit there and say, though, the United States is one of those examples of where we're definitely in transition. What's causing those high population growth rates is not a high birth rate, it's a high immigration rate. A lot of people are moving into the country. So I would say it's a little deceptive to looking at these numbers sometimes, which is one of the reasons why determining demographic transition from population growth rates doesn't always work. And you're going to see when it goes, and you can kind of see why, because immigration can really throw things off. Next idea: how to calculate population growth rate. This is really easy, guys. I'm sure you guys can figure this out. This is basically take the birth rate, how many babies are you having, minus the death rate, then add in migration. Migration is just immigration minus emigration, and divide it by 10. So here's my example. I took the United States, has a birth rate of 14.1, a death rate of 8.3, and a migration rate, like I said before, has a very high migration rate of 2.9. You put this into a mathematical formula and you get 0.87. So you can see that the United States is definitely in transition. We have a low birth rate and a low death rate. We just have a lot of migration coming into our country. Okay. Next idea the book talks about is called zero population growth. This is the idea where birth rate equals death rate, and immigration and emigration are about the same. This is usually considered to be a good thing because you no longer have to worry about limiting factors coming in, because if you have enough food for 20 million people and you only have 10 million people, you never have to worry about having that population slide off. You can also put more resources into other things like technology and stuff like that rather than food production. Excuse me. So zero population growth is usually considered good by biologists. I will say this. It's usually not considered good by economists. Economists don't like zero population growth because economies depend upon constantly increasing population sizes because they want constant growth. And this is usually created by having constant increasing population. So economists don't usually like population, don't like having ZPG, but biologists do. There's probably some happy ground that we're going to have to come to a conclusion on in the middle somewhere at some point in time, because as you guys know from limiting factors, the economist's point of view will never hold because you can't have infinite population growth. But the biologist's point of view won't hold fully either, because you still need to have economic success. Otherwise, people tend to get a little bit irritated when they have no foods and no Xboxes. Okay, age structure. The best way to show age structure, and just to tell you what it is to look at it. Age structure is a type of graph. It just tells you how many people, what percentage of the population exists at what age group. So here for Kenya, these people would not be in transition, and I'll explain why here in a second, because they have a lot of babies coming in the world. They have a very high birth rate, which you can see from the number of people between the ages of 0 and 19 years old. And obviously, as you can tell, there's a very low rate up here. That means this country is definitely not in demographic transition. So, and they are not at zero population growth, because this group right here, this 10% of 0 to 4-year-olds, is going to be moving up like this as they get older, assuming they don't die due to things like famine, disease, and things like that. Now, if you look at Germany and the United States, the opposite is true. He goes, we are both in demographic transition. And if you look here, it's because it's mostly even as you work your way up until you get past the 50s, which people begin to die of like heart disease and cancer around here. Unless you're a woman, and you're lucky because there's more women staying alive than men. Sorry, ladies. Or sorry, guys. So he goes, this one's in transition. You can tell because it has this almost even pattern as it goes up compared to this pyramid-like pattern right here. Germany is also in transition, but they're in negative growth, and you can kind of see this because this part right here is bigger than this part right here. So these guys are definitely experiencing a negative population growth rate. So for a quiz, I will definitely ask you guys to determine if something is in demographic transition or not based upon these graphs. So if you see a pyramid shape like you do with Kenya, we're definitely in transition. If you see an even shape like this, we're not in transition. So how to find this information? There's a practical exam coming up here in a few weeks, and I'm going to have you guys do research as part of the practical exam. Here's my tip for you guys. If you need to find the age structure or any population demographic information, the CIA World Factbook is your place to go. They maintain databases on pretty much every country on Earth, and they talk about their age groups, they talk about immigration, emigration, what kind of cultures they have. The CIA does a kind of a scary good job at this. How to find it? You must want to choose your country, go to the population and society, and it'll give you the and there's a little thing you click on for the population pyramid somewhere within this tab right here. And that's basically the age structure I talked about beforehand. And that's it, guys. Thank you for watching the video on Chapter 4.2. If you have any questions, feel free to come see me in class or ask them on Edmodo, and I will get to them when I see them. Have an awesome day, guys.